Uh, by last class, we have completed the Kubernetes. We have seen the plenty of Kubernetes resources, how to use those Kubernetes resources in different conditions. So today we are going to see the Helm. Helm is one of the Kubernetes package manager. Why it is called as a package manager for Kubernetes? Uh, whatever the files, the manifest files we have seen in the Kubernetes, like deployment services, everything will be handled by this Helm. All the files as a single point, we will be managing all these files. We'll make a bundle and then we will deploy it across the different environments. So if you do this kind of bundle of this manifest files, it will be easy for you to get implemented in various namespaces or in various environments. So that's the one of the use case of Helm. So because you are going to deploy some microservice, so it needs some deployments, it needs some service accounts, it must be contain some secrets. So you cannot each and every time you cannot create those files manually each like one by one. When you have an when you like bundle your application into LM, so you will put all the service into it. You put all your secrets, libraries, everything into it. So when you want to run that application, you can just by using the simple elm column command, you can simply install the application so it can run for you. So that's the use cases of Elm. Um, so in Elm, mostly you will be hearing the word called chats. The chat in sense what we call as chats. So we call this manifest files as the chats. So inside the chat in the templates folder, you will be having different deployments and service accounts, config maps, YAML files. Like that's how the chats folder will look. So related to Elm installation, so in one of the slide, I mentioned how to install the Elm on Windows. You can go through it. So this installation would mostly will looks like. I will help you in the installation as well. So I have already installed the Elm in my local. So what you have to do here is like, wait, let me check the volume. You just go to the link which I given in this slide. So it will be redirecting to one of the GitHub where you can see Windows AMD 64. You just click that. So it will download you one um, archive file. This is the archive file, the zip file. So you extract the zip file and then put it somewhere. You will do the extract. Will click right click and do extract all, and then you will see a folder like this. In this folder you will be having you will have some file called elm.exe. I copied this elm.txt file into my C program files. Inside I created a folder called elm where I pasted it in my C program files elm. I pasted that elm.txt file, and then in the environmental variables, like in your Windows, you have something called environmental variables. So in the environmental variables, you just open, and in the system variables, there is some variable called path. uh, you click that, double click the path, and you add this. You take this element repository wherever this exe file exists. You copy this directory and put it in the uh, path here. You add a new entry. So and then you paste it and save it. So that's how the installation will be like. See, most of the DevOps tools installation will follow the similar method. So I have listed everything here. Go to this GitHub repository, download the Elm, unzip it, copy that elm.exe file, and put it in the C drive in the under the program files or in anywhere. You can put it in any directory. So I'm just giving you a definite path here, and then add that path in the environmental variables, and then Elm will be available for you in your local. You can verify that by let me open my project. You can verify that by running the command um, Elm version. You see, version 3.18.4 is installed in my local. So what now? Let's straight away see some Elm repositories. So this bit like you can put this Elm charts in different repositories. Like we can put this Elm charts in GitHub, and one of the common way to store this Elm charts is Bitnami. So this, if you go to charts.bitnami, wait. So this is one of place where you can store your uh, uh, where you can store your charts. So mostly what you have to do is like first you have to add that repository in your local, and then search for the repositories that you want to install, and then install the chart. So what I will do in my local. So first, you have to. This is already added in my local. So what you have to do is like you have to execute command like elm repo add bitnami and the URLs. Okay, in this URL alone, like in the charts.bitnami.com/bitnami, you have most of the elm chats that are predefined for you. For if you consider a simple application like Nginx, they have this. They bundle this chat and they put it. The command is like uh, elm repo. I'm adding a repo and add bitnami means I'm giving any name to that repository. The short name for it is like bitnami, and then if I add it, you see bitnami already exists with the same configurations, so it's skipping. If I do elm repo list, now you see, yeah, Bitnami is been the name for the chart is Bitnami, and the URL representing it was the starts.bitnami.com. So that's how you should add the starts, because there would be different uh, areas that you can host these Helm charts. Like mostly we will be using some standard Helm charts, because in Kubernetes, apart from whatever the files that we see in the last parts in the K8s, these are some files that we write related to our applications. But in mostly you will be consuming some of the third party tools from the internet. So those things need to be installed by the Elm only, because it will be very easy for to install, like the ArgoCD, like Prometheus, Grafana, or like some AGICs, like ALB, Ingress, like Ingress controller. Everything you can install by the Elm charts. It will be easy for you to uh, do this installation of any particular third-party softwares by using the Elm. So I added the Bitnami repository in my local, and then you run a command called Elm repo update. So what this command does is like if any of the chats is being updated, so that you can see each and every time you after added any if you are doing some any elm install means like you install the chats. Before that you run elm repo update, so it will, because in my local when I was using this elm, there might be an like older version, like consider it as 1.0.0 something, but today somebody released a new version in the internet, so it has to be downloaded here, right? So if you do elm repo update, what are the elm repo list where I have bitnami and ghosted, right? If any versions has been released, it will get updated in the backend. That's the thing. See, successfully got an update for the argo chart, successfully got an update for the bitnami chart repository as well. So that's it, update completed, happy elming. So now, because both these stats I used it long back, so now both the stats something they updated. So now this repository files got updated to us. So just observe these things. We will, because this is not first like in first time you cannot get all the inputs. We will see each command by command. So now what I added a repository here, right? Now Bitnami is added. Now what I do elm search repo Bitnami. What this does is like in this is Bitnami. So this Bitnami points to this starts.bitnami.com, right? In this URL, what are the standard charts are available. You can see if I type this, you will be seeing a whole big of list. So Elm search, maybe I can put it here. You see how many charts are there, you can see. So these are the some of the standard charts that are available for us in the Bitnami. You see, Airflow is there, Apache is there. So I know you might didn't know about these things, but you see, Argo CD is there that we are going to see today in after completing Elm, and then you see like Grafana is there. You see, and then what else is like who you know like Messi MariaDB is there. MariaDB is like an database. So and then see Prometheus is there, RabbitQ is there. These are some messaging service. So all like Tomcat is there. Tomcat is also is like one of the web server similar to our Nginx. See WordPress is there. WordPress where which is used to host some websites. See mostly these are the charts that are available for us uh, in the Bitnami. Now, if you check for some Nginx, because I'm going with some example from Nginx this class, from C, Bitnami Nginx is there with the version 21.08. The first one represents the chart version and the app version. Chart version means so in this chart you will be having this deployments and manifest this Kubernetes manifest file, um, and the original version from the Nginx it's 1.29. Okay, that's the meaning of this. This first thing, this chart version means you updated your chart and you want to give your chart some version. So that version from the Bitnami side, they're maintaining this repository, so they are updating the version into uh, some number. Okay, if you consider this Nginx, this 21.08 points to the chart version, and the 1.29.0 points to the application version. Some Nginx, right? They update the Nginx and push the version, right? So the application version is 1.29. So that's the meaning of this thing. So let me uh, uh, do one thing. So what I do is like now now what I want to show you is like now I do elm template, and then I give some name. I give my project name as some Phoenix, or I give something as Nginx. Okay, and then I give bitnabi slash Nginx. What it means? I am elm. I'm going to use the elm, so I'm giving the elm command, elm template, nginx, and this is the name for your chart that you're going to install, and then I'm going to give us bitnabi. Bitnabi in from the bitnabi, I'm going to use nginx template. So we have bitnabi slash nginx here, right? So this is what this is what I have been representing at the last. If you do this thing and then enter, you can see what are the Kubernetes manifest files that is going to be deployed for you. Let it run. It's taking some time. Now see it is completed. If you see my screen now, see the whole big list has been come. See when I run Elm template, and I'm just this is the name of your Elm, and then I give bitnabi nginx. You see what is creating a network policy is getting created here, and then pod distribution budget is getting created, service account is getting created, secrets is getting created, and then service is getting created, and then deployment is getting created. See in the whole package you have the complete so when we were writing this Kubernetes, right, each and every time we go to this Kubernetes.io documentation page, and then we copy this and then we edited this. Now you have a complete bundle here. So for Nginx, there is already a bundle. You can straight away install this bitnabi repo and then you can use it. So these are the files that is going to come with us when we install the nginx in our local. So okay, let me, what I do now, my Docker is running. Also, I have my Minikube is running here. So what I do now is like, now we're going to actually install the if you see kubectl uh, get pods or something. Hmm. You see there is no pods running in my default namespace. Whatever the resource that we executed in the last few class, I have deleted all those resources. Now what I'm going to do, I'm going to install the Elm chart. If you do Elm install nginx, this is just a name for the chart, and uh, this nginx. Now I'm going to install this one. Now you see Elm, after I type the command, see the chart name I have given as nginx. You can give any name. Here you can give my project, my application. You can give whatever the name that is very convenient for you. You can give it. See, it is deployed in the default namespace because I didn't specify on which namespace it has to it has to be deployed. If it has to be deployed in different namespace, you have to specify -n and then the namespace name. See, and the revision is 1, and then you see the chart is nginx. The chart version is 21.08 and app version is 1.290. Now you see it's completely installed, and it is giving plenty of other information as well. Export, it's giving some other informations. Skip about that. What we know is like when you receive the commands like the status is deployed, the Elm chart has been deployed for you local. How do you can check? You do Elm list. If you do Elm list, you can see uh, nginx stat has been installed in the default namespace with the version 1 and the updated time and the status and the chart and app version. Now how I can see the applications that were deployed by using my what are the applications that deployed by this Helm chart? We already know, right? When we were done the employment, we are seeing deployment services and everything, right? So in order for you to when we done kubectl get all, it will show you deployment spots, replica sets, and everything that installed in the default namespace. So I'm going to add one -l. -l means label, because when I install the this Elm charts by this Kubernetes resource by Elm chart, so it will by default going to tag. Okay, it is going to I know it's going to tag with app.kubernetes.io/instance. So this flag will be default, will be present, and the value for it would be like your chart name. Your chart name is like nginx, right? So if you give that, you can see what are the resources that has been installed for you in this uh, in the default namespace. You can see your pod has been running for you for the last 2 minutes, and then service has been running, and then deployment is running, and then replica set is running. So this is the basic about C. Previously, when you tried to execute, and then if you see, we were seeing some service accounts as well getting created, right? When we were doing this templates, uh, deployment is there, service is there, some secret is there. kubectl secrets. You see, like nginx-tls secret has been created in the last 3 minutes. Also, you see one more version here, right? Like elm.release v1 nginx.i1. So this is each and every time you do some elm installs, and another version is a secret is going to be added in the default namespace. Okay, so this application is deployed in the default namespace. That's why you see a secret with here with the app version. Okay. Now see all the resources for you is installed here, and you see it's very easy. You no need to write services, deployments, and replica sets and secrets and other Kubernetes resource. You just need to install it. Now it has been installed. You see this nginx-tls secret. is being used by the application. This one, it points to the release. This version release, it's a version 1, right? So if you type Elm history nginx, uh, if you type Elm history nginx, you see you will be seeing a plenty of versions here. This is my first version, and you in the kubectl get secrets, you see an secret created for this version. Now what I do is like I want to upgrade my version. Okay, um, so before that, so f- in order for me to know what are the, because this stat has been created, you don't know how this stat has been created. So if you needed, you want, if you feel like I want to use this nginx template from the bitnami, but I want to change the image. Okay, instead of, if it is using some image like um, you see, right, it is using nginx docker.io bitnami nginx, it is using 1.9.0 and debian 12 r4 images instead of this image. If you feel, but my application should use some other image, in those cases first you have to know what is the variable that is being used there, and you want to know how you can replace that. To for that, so there is a command called lm show nginx, and then okay, and show values, elm show values, and then bitnami slash nginx. In this particular nginx stat, what are the variables that available to you, so you can modify it during the during the runtime. So if you type this command, it will show you all the variables that listed in the nginx stat. See, you are getting a complete file here, right? Leave about this hash lines. These are commented lines. Apart from this commented lines, whatever you see, those are an arguments that you can pass, that you can change during the uh, runtime. I know this is very big file and you don't want to go through this, so I want to do some grep here. In Linux, what you in grep to and an imagement. So in this complete list, I want to see where the image is present. You see, it's giving me the filter wherever the image variables are present. So what I'm going to do is like now in the same see, now you see my command, instead of elm install, I'm going to do upgrade. And what I'm going to upgrade, I'm going to upgrade, you know, my chart name is, and I have given as nginx. I'm going to upgrade the chart. It is running in the version 1 now. Now what I'm going to do, I'm going to change the service type as node port and then replica count as 2. When we were running it, we were seeing only like two replica count. We were seeing like only one replica count. I'm going to change the replica count to 2. That means 2 pod is going to run. Now you see Elm upgrade nginx and bitnami slash nginx and hyphen set. See, I'm just setting a variable hyphen set, and in the service dot type you have the option to change, and hyphen set in replica count you have an option. So how I can verify that? You can go through this file. Mm, you can go up. You see, in this complete file, there is service is there, and then inside the service, there is something called type is there. The type is load balancer. So if you want to change this, you what you have to do is like you have to give the flag as hyphen set and then service dot type. So similar to that replica count also. Uh, this how you should be given. So if it's a mostly it will be some list and dictionaries only. So this is how you should specify service dot type. If in the type, if you feel like inside this type you have some other argument, then you should be like after type you put a dot and then give that variable name. That's how you should set it. Now I'm upgrading my chart. Mm, I have pressed enter. I'm waiting for it to get upgraded now. Now you see what happened. Previously our Nginx Helm chart was running with the version 1. Now it is showing the version 2, right? Now how we can check that? If I type Helm history Nginx, Nginx is, now you see previously a version 1 was there. Now see it's got superseded. That means it is still there. It is got superseded. It went back. Okay. So now a new version got version v2 is been deployed. If you check my kubectl get all, now see two pods are running. First pod was running for the last 10 minutes, and the new pod has been running from the last 42 seconds after we updated a new version. Okay, so and if you feel that in your new version, if you feel like you have to revert back to your older version, or some, if you feel like the second version has some issues, you can do easy rollbacks as well here. So the command is like lm rollback nginx version and then the version. So I'm doing rollback. Rollback means now the current version is 2. I want to go back to version 1. So in the version 1, what we know, it will be running in the single pod only, right? So I'm giving elm rollback nginx and the version is equal to 1. After you type, I think it's -2 version. One second. Ah, you don't need to mention the version things here. You just mention the version here. It's 1. Now you see rollback was successful and happy LME. If you do LM history now, what would have been happened here is like, see, this is your first version after a second version has been deployed, and then see what is the description here? Rollback to 1. That's the third version represent. While you were doing this LM rollback, a new version has been added, and in the new version 3, whatever the changes that you add in the version 1 has been added here. So that's the meaning of these things. So uh, so let me add these comments for you here as well. Um, up till this, do you have any doubts, Lokesh? You have any doubts until this? You can unmute yourself and ask. Uh, I hope there are no doubts now. Um, Let me move to the next topic. So, whatever we have seen up to now is to like use any standard charts from that is available in the different repositories like Bitnami, GitHub or something. So what we are going to do is like I'm going to like first uninstall here. So the command is used to like to delete all these charts is like elm uninstall and then the chart name is nginx. Uh, after you did history also, you will not be seeing anything because there is no chat is available. Nginx, the complete history will be deleted when you do Elm uninstall Nginx. A complete history of this chat will be gone, and you will no longer will see any resources related to that application. Okay, you see the kubectl get all, then there is nothing running here. So the next topic would be like, so create some your own charts. Okay, whatever the own chart that you feel that you want to run, you can create that by using this Elm. Okay, that's a main use case because each and in your organization you don't want to write this files manually. You create this Elm templates and keep it. So you by using this Elm commands, if you try to install it, it will be very easy for you to get deployed in different environments. The first thing about this thing would be like, you ignore all these files. I'm closing these things. Mm, I have installed the Nginx chart now. Now I'm going to create my custom chart. What is this custom chart? Let's go. Let me create Elm. Create. I want to keep it the name as Phoenix for my custom templates. If you do Elm create Phoenix alone, you see creating Phoenix. You see a repository Phoenix has been added to me in my local. If you go inside that, you will be seeing different folders here. Okay, you, the first thing would be you have some values.yaml files. As I told when we were seeing this Elm, we we know the replica, we were modifying this replica account, and then we were modifying this service type, right? You see all the values here. So all the variables will be present, variables and the values will be present in the values.yaml file. You can just modify it, or during the run command, if by using the hyphen set argument, you can just pass the value for that argument and you can change it. So all the variables and values will be present in this file only. Like image will be, the repository will be nginx, what's the tag that you want to use, if any image pool secret you are using, or any service account, whether service account creation need to be done or not, and pod annotations, the label and annotation sections, and service ingress sections, liveness and readiness. So you can see the entire thing here in the values.yaml file and in the chart.yaml file. So for your application, as similar to Kubernetes, you have API version here. The name of my chart would be Phoenix, and then some description has been added here, and the type would be application, um, and the version is like 0.1.0, and my app version is like 1.16.0. So this version points to your chart version, and then this app version points to your application version. Whatever the whatever the version that your application is running in your organization, you can keep that version here, or you can leave it as well. So mostly nobody is going to continuously change these chart versions in their custom templates. Um, those details will be present in the chart.yaml file, and you will see a elm.ignore file, because if you want to, what this elm.ignore file, while you create any elm charts, if you feel like some of the files that not to be included in my chart, those files should be present in this in this elm.ignore file. See whatever like git ignore and bzr ignore, this is just a ignore file. So while considering the Elm, while running the Elm install, it will not consider these files for Elm installation. That's the meaning of this Elm ignore files. And you see one more folder called charts, and one more file called templates. So inside this templates, you see inside this charts, if you want to, if you have different microservice, and under the charts you put your all your microservice, and inside this charts folder, and you and then similar to this template, you copy this template folder and you put it inside that. So you consider your like your your application is going to be web. You inside the charts folder, you create a one more folder called web. Inside the web, you will be having this templates folder and this values and charts YAML file. That's what we call, that's what we most basically put in charts. So here we are not going to see, we will going to see a simple templates here. You see inside the templates folder, you have service account.yaml file, but and then you see service.yaml file, and then you see ingress.yaml file, and then you see HPA, horizontal pod autoscaler, and deployment.yaml file, and you see something called helpers.tpl file. So, but in the Kubernetes manifest file, you see the formats are changed little bit. Why it has been changed little bit, you see some condition as well, right? You see include phoenix that full name, and then you see something called um, include phoenix that selected labels. You can see all the sections of deployment, but in addition to that, you see this curly braces and some of the condition has been added here. So if you go to your helpers.tpl file, you see all the definitions here. So this helpers.tpl file is mostly used to support your uh, manifest files like this deployments or YAML file. If you check in the metadata section, I have a phoenix.full name, right? You just copy this phoenix.full name and come to helper.tpl file and search for it. You see define phoenix.full name, and you see there is something called if values that full name override. uh, if it is, if this condition is true, you change the you trim the suffix. That's the meaning of this thing. So you see different conditions here, right? You see different definitions here, like define phoenix start, define phoenix dot label, define phoenix dot selector labels, define service account. See different definitions are there. If you and different if conditions are there. So this then for simple, in order for you to consider a simple block here, um, consider this thing. So here define phoenix dot service account, and then there is an hyphen. The start, it should open in the in the function definition. It should start with two curly braces, and it should end with the curly braces, and then it should start with hyphen and it ends with hyphen. You put a define section, and you put the chart name and whatever the variable name that you declare. That service finish account name is there, right? In the if condition, if values dot service account is create means, if it is true, if you go to values dot yaml file, you see here, at the last, uh, here see the service account create is equal to true. If you go to the helpers.tpl file, if value service account is true, then by default the Phoenix full name should be given for the service account name. That's the meaning of this thing. Okay, if service account creation is true, then include means it includes this function. In this function, whatever the name that you get for your chart, that should be applicable for this service account name as well. Values dot service account dot name. You see values, this is the values file, and in the values file you have service account, and you have a section for name. So that's how you give a name for this service account. So that's the use case of this helper.tpl file. You no need to spend more time here. Once you started working it, you will be get more familiarized here. So now consider, I have this chat with me. Mm, I consider this chat is with me. If you feel like I have to create this chat, then by using the same command, whatever we created, I'm going to install it. If I do elm install and give my chart name as Phoenix, and then the directory name is like Phoenix, right? So because I'm actually in my Phoenix project and this repository is created in the Phoenix, so I've just give elm install Phoenix slash hyphen Phoenix. Once you created this Phoenix folder, you modify your Helm charts as per your application needs, as per your client need, and then now you see what happened here. Like it has been deployed successfully. If you do Helm list now you see a Phoenix Helm chart has been created here, and it is running with the all the default configurations. I didn't change anything. If I do kubectl get all, you see Phoenix pod has been running, service has been created, deployment is created, and replica set is created. So, and if you see kubectl get HPA, oh, HPA is not get created because I think auto scaling is like not enabled yet. If you see values, auto scaling something is there. Uh, I think auto scaling parameter by default it's false. That's why it's been created. You see, that's the use case of this thing. Now what I do, let me uninstall it and then let me uninstall this one. So that's how you create a custom chart in your local and then you run it. So I'm going, I don't want to it to run now. Uh, Now I'm going to uninstall it. Now it's in uninstall. Don't, that's why you will not be seeing any resource now. See, all the chats that we were seeing here has been deleted. So that's the basic about Helm. Uh, Lokesh, any doubts we have in this class now? I'm taking it as a no. Uh, I don't hear you. Okay, let me. Yeah,
Hello?
yeah. Any doubts that you have in the Helm
Hello?
charts? Yeah.
Yeah, no doubts, Satish.
Okay. Let me move to the next topic. This is how we use Helm. The next topic could be like ArgoCD. What is this ArgoCD and why we needed that? So we will just cover it simple. Hmm, if you consider um, like each and every time in the organization, like let me take my phone. Each and as I said in my previous classes, so mostly the CI pipeline will be different and the CD pipeline will be different. In the CI pipeline, what are the things will be like? It will involve the code checkout, and then it will have the unit test, some unit test will be there, and then there will be some SAS testing by sonar, check to check the quality code, and then something the quality gate will be there. If anything's failing in the sonar, we will put the quality gate here, and then we have the Docker build here, and then we have pushed this Docker image to Docker Hub or to ECR. Okay, mostly we will be pushing the image to ECR. This is what mostly going to be contained in the CA. The CD part, how it's going to update it. So there will be some question, right? Consider you throughout this pipeline, you made some image update, and then you pushed the images to the ECR or something. But when we were seeing the CA pipeline in the Jenkins class, we were finally pushing some images with some tag name, right? Consider my application is like Phoenix, uh, at hyphen. Uh, After colon we were seeing some version, right? Consider like 5 or 6 or something, like anything you can put it, like some numbers will be there. Sometime will be the original app person will be like 6.0.0 will be there, or sometimes some custom flag will be there, something related to your branch name will be there. So okay, you update that image, like, right? After the CA pipeline completed, one more step will be there to update your Elm chart. You can follow this flow. After the image has been pushed to ECR, you update your wherever you separately host your Kubernetes manifest in GitHub. Okay, like this, um, like um, like I have a folder called ArgoCD here, right? In my Phoenix project, I have deployments like HPA and everything, right? So here, instead of this version, what your pipeline is going to do is like update with newer version. Okay. Um, so update that Kubernetes update the Kubernetes manifest with the latest image tag, whatever that we will build in the pipeline. Consider I have a image build number with 25. Update this manifest file with version 25. So here in my Argo CD folder, I have deployments, right? Here I'm just putting it at 1.4.2, but this is how the actually things will go after you made the CI/CD completed. you update this Kubernetes manifest file, this file, this version into 25. You can, if you can ask me how we can do it, there is something called set commands that we have already seen in Linux. Consider like in set command. So by using the set command -i and then the parameter that you have to change, you put some image, constant image tag here, and then the new build number, and then the file name. This will be your last CA stage, and then the KATS will be updated with the new image tag. So this file will contain what the image number 25 now. So after that, uh, mostly if Argo CD is present in an organization, Argo CD will checks for your manifest updates in the GitHub. Consider this is being hosted in the GitHub, this K Argo CD files. And then what this Argo CD will like, it continuously checks your GitHub. If any version updates in the Kubernetes manifest file, it will do the deployments automatically. This will be one flow. Okay, you update this thing, this will be one flow. Just stick to this flow. One more flow will be like, after this ECR image been updated, you will be just how to somehow pass this build number into your CD, or like while you run the CD, you just specify the build number, whatever, because the image has been pushed to ECR, right? You will be just specifying the build number here, and then the environment, like it's dev or QA or pre-prod or prod or DR environment, wherever you want to do the deployment, and then you deploy it. That's how the flow will be. Either you do the manual deployment, or by using Argo CD, we will do the automatic deployments. So these are the CI/CD flows that we actually have in the organizations. So mostly this flow will be same. So they in some of the organizations they would have some artifactories like Nexus or JFrog to store this build artifacts. When we were running Java, right? When we were doing this Maven package, it will actually create a jar file. Somebody needs to store those jar files. They will put the jar files in Nexus or JFrog. That except apart from that, there will be no changes in the flow. You can just stick to the these two flows which I told. Now we are going to see the first flow here. Once the ECR image has been updated to ECR, consider your CI pipeline updating the manifest with the some image tag here. The whatever the image tag, like it's 25 or something, it get updated here. And then there's something should be present, something called Argo CD. What this Argo CD will do? So this Argo CD, consider consider it as your GitHub. Consider as your GitHub. Okay, GitHub. It is your Argo CD. It is my GitHub. So if any image update has been updated to the manifest files in the GitHub, Argo CD will fetch that and then deploy into your Kubernetes cluster. So that's the duty of this Argo CD. So let us go to the architecture of Argo CD first, and why we need this Argo CD and everything. So that's the use case what I were told, to do this automatic deployments or changes before the changes, whatever the new changes that going to come in the Argo CD, that is going to be get tracked here. So you see the user will be there, one API server is there, and repository service is there, and application control is there. So in Kubernetes architecture, you can consider you have four major components. Here I didn't show the one more component. You can just ignore that. Um, these are the three major components. One will be the API. In the API only, it will from the browser. Now we are going to access this Argo CD, where you have to deploy them as a Helm chart in the Kubernetes, and then we will be accessing from the browser, and then we will do some stuff there now. So this API will be responsible for all these things only, and then this repository service will be responsible for you to continuously check the GitHub. it will be continuously check your GitHub if any applications are getting updated, like any repository, any Kubernetes manifest are getting updated some with some image tag or some new deployments has been added or new Kubernetes resource has been added. Repository service is constantly going to check that, and then it gives those changes to the application controller. Application controller will take care of those changes and do the deployment in Kubernetes service. So for you to understand simply, I have written, you can see the GitHub flow. The Argo CD is a GitOps tool. GitOps means Git and operations. That's the meaning of thing. You see, repository server fetch the details from the GitHub, and the API server, we can see these changes in the UI in the browser, and the app controller will fetch the details from the repo server and then push the changes to Kubernetes. So this is like a pull based model. Okay, here you no need to do anything. uh, Once you push the changes into GitHub, Argo CD will directly pull all the changes it will check all the changes and push the changes to K8s. That's why it is pulling, right? It is pulling the changes from GitHub, right? That's why we call it as pull based model. For now, you just get stuck. This is enough. I'm not going to do deep dive here. So what we have seen. We have seen the Argo CD, why we need Argo CD, and what are the Argo CD components that we have. Now what I'm going to do is like I'm going to install the Argo CD by using the Helm upgrade. So I already did the repository update. You see, I have a command like Helm repo add Argo and some URL here, argo proj.github.io argo Helm. I have already added it, and I did the Helm repo add as well now, right? Now what I'm going to create, I'm going to create a separate namespace for this Argo CD. Okay, I'm going to create a namespace kubectl create namespace argo cd. Now a separate namespace has been created for the argo cd. As I told, the Elm will be using Elm to install some third-party tools inside the Kubernetes. Now I'm running my Kubernetes cluster. Now I created argo cd. Now what I'm going to do is like I'm going to run a command here. You see the commands here. You see, I use Elm install. I'm giving my chart name as Argo CD, and you know I added that before this command Elm repo list. You see, right, in my repo list, I already have the Argo. With this URL, I'm giving a name as Argo. So if you see my command now, Elm install Argo CD is my chart name. This Argo CD is my chart name. In slash Argo, I will be having Argo hyphen CD. Chart is present, and I'm going to install it in the Argo CD namespace, which we created in the last step. And I'm going to set the service type as node port. Okay, that's the meaning of this thing. Now, once you started running, you will be seeing in different resources in the Argo CD namespace. Then let's see it here. Now you see, now what happened is like Argo CD is been started to work here. If you see kubectl get all hyphen Argo CD. So we know I'm going to list all the resources that's installed in the Argo CD namespace. You see what are deployed for me. Uh, the main components, you have to consider like one more component is a dex in the Argo CD architecture. It will handle this SSO means single point of login. What is the single point of login? And just give a overview here. In most organizations, your username and password will be present in somewhere. Uh, in if you consider like AWS, your account is hosted in AWS, right? If it is hosted, your username password will be present there. Okay, so you have your organization have some third party tools like you have Jenkins, you have some Argo CD, your company have some Terraform cloud or like some Sonar cloud is there. So if you have your account somewhere like you are hosting your account somewhere in like AWS or something, we can use something called SSO. SSO also means single sign on. So if you have account here, they can do this connectivity. They will have the backend, they will take care of this identity provider connection. So your Jenkins, in the Jenkins server also, by using the same AWS account password, you can log in Sonar Cloud also, you can, by using the same account password, you can log in Terraform on cloud also, you can log in by using the username password. That is what we call single sign-on, because you no need to create different username and different password in different areas. This is taken care by the single sign-on. So this is one of these component that handles this single sign-on. So if you see kubectl get all hyphen and argo cd, application controller is running, dex server is running, and then repo server is then running, and this argo server is running. Argo server means this argo API or argo UA. Okay, now you see all the services are started to run. Now what I am going to do is like, um, it, uh, now it started to run, right? Now what I have to do, uh, hmm, I know when Argo CD started to run, what I'm doing, you see, kubectl get secret, and the secret name is Argo CD initial admin name. This I know the secret will be created in the namespace Argo CD, and if I know I'm taking it in output as a JSON path, and in slash data password, so this UA password will be there, and then what I do is like I decode the password, because we know whatever the values that we put in secret will be in base 64 encoded. Okay, we remember when we were saying Kubernetes secret, whatever the values that you put in, in the secrets, it should be like base 64 encoded, right? So I take that value and then I decode it. That is what this command means. Now you see, this is my password. Okay, you just keep it somewhere. I just copy it, and then put it somewhere else. Hmm. Now, what I'm going to do, the last class when we were doing Ingress, Nginx and all, we were not able to display the application in from the browser. It is because I'm running my cluster in Kubernetes, right? This is my consider this is my laptop. This is my laptop. This is my mini cube. Okay, I'm running it as a somehow I'm running this minikube as a container. My physical host and minikube was not attached. That's why when I was running Kubernetes Ingress, or I was running the node port service, it is not getting any external IP here. If external IP, it should get an external IP. That means my laptop will have some IP, right? That IP was not attached to this minikube. It's default only. There is no attachment is there. So if it is if the minikube gets that in external IP alone, we will get the connectivity there. So now we started to run this Argo CD to I know there will be no connectivity will be there. So I am going to do some port forwarding. Okay, you see here, I run some command called kubectl port forward, and the service will be service. If you see here, uh, you see I have a service something called node port, and Argo server is running in the node with the type node port, and it has some port forming with 80 and 3008 and 443 30443 here. So I already have a service here, but it is not exposed to the internet due to my um, I'm running this in Minikube. So what I'm going to do is like port forward hyphen Argo server, whatever the signal that in my local host, whatever it's like 8080, run it on 443. Okay, and now you see port forwarding is connected. Now my local host, whatever uh, the local host, the port 8080 is connected to 443 of the Argo CD server. We know, right? Argo CD is running in both 80 as well as in 443. In 80 it will be HTTP, in 443 it will be HTTPS. I connected with HTTPS now, right? Now what I will do, um, I go to my my browser. Right. Uh, Now if I type HTTPS, uh, localhost 80 is localhost means I'm pointing to my local machine and I'm then running in 80. I know there is no SSL certificate is there, and in the advanced section you click the advanced and proceed to localhost. Now you see this is how the Argo CD UI is mostly going to look, and the username must by default it's admin, and the password is the password that we fetched previously is this one. You copy and put it, and then you do sign in. See, this is how the Argo CD UI is going to look. You don't need to consider anything here. There is some user section is there, and then some settings are there. You no need to get much familiar with this thing because Argo CD is just a simple tool, but it has good scope. So here, what I do is like after I come to this Argo CD UI, I am going to create a new app. Okay, so I'm going to create a new app and I'm going to give the app as Phoenix. I'm considering my application name as Phoenix, and the project name it should be default, and then the sync policy, as I told, Argo CD either can pick up the changes from the GitHub. What's my plan is like, for Argo CD. I have put all the basic chats in the Argo CD folder in my Phoenix repository. You see, this is my Phoenix repository. Inside, I created Argo CD. Inside that, I added basic files. All these files we already seen in the previous class itself. I have some simple deployments here, and then some config map is there, and some HPA is there, and some ingress.yaml is there, service.yaml file. This all these configurations we have already seen, and it's available in the K8s folder as well. I just took the it from there and edited a little bit and put it here in the Argo CD folder. Okay, my plan is to like, so whatever the files it's a public repository, so you no need any authentication. Whatever files in the Argo CD files, it should be get executed now. Let me go to my Argo CD UI. I given the application name as Phoenix, project name as Default, and the sync policy is manual. I don't want to do the automatic deployment, and I give this option as manual. It is asking for my repository URL. I'm This is my repository URL. My repository URL is this one. Uh, this is my repository URL. It is like github.com slash Satish hyphen DevOps 03 Phoenix. Here you can mention wherever is a branch. It means wherever it's currently pointed. That's the meaning of it. You can give whatever branch you want or the tags that you put. I'm just giving it as edit itself. And then in the path, in the root folder where I have in slash argo cd, I have these files. So I'm giving like dot slash argo cd and then slash. So inside this I have all the files. So where you want to deploy these things. So here in the designation, this is the default URL because I'm going to run in the same cluster where this Argo CD is running. So I just give the URL. So mostly this is how the URL for you in the local host, because Argo CD and this service is going to be deployed in the same cluster. So it will be like kubernetes.default.service, and I'm going to deploy it in the some different namespace called Phoenix. So we know this namespace is not created. So there is in sync option there is an option for you called auto create namespace. That means if this namespace is not available, create it, and then that's it. You create. You see, yeah, you after it got created, you see plenty of other options came for you, and you see Phoenix is been created, and if you click that, see it is out of sync. Out of sync means still now in my Kubernetes cluster, it's running. Let me take one more bash shell here. If you see kubectl get ns. because I plan to deploy this files whatever I mentioned in the ArgoCD folder in the Phoenix namespace. But still now we don't see any namespace called Phoenix, right? Now I'm coming here. It is out of sync, right? So inside that application, I choose the sync and then I give synchronous. Now you see it's saying it is getting synchronous. So this is this application name whatever I have given is Phoenix, and it has created config map, that the short form of its CM. App config is created, service is created, deployment is created, HPA is created, ingress is created, and this deployment will create replica set, right? And this replica will create it nginx. What it says, all of things you see it's running everywhere, it's showing green mark. Hmm. Now you see everything is been created. Now if you go back here and then if you see kubectl get ns, you see a Phoenix namespace 41 seconds is before it created, and you see kubectl get all hyphen n Phoenix. You see pod service and everything is been started to run. Now what I do here, I will delete this chat. I don't need it. Uh, Here I'm going to add one more file. Mm, uh, or in the deployments, I change the version to 14 to 15. Sorry. Mm, I changed it and then updated version. What happened here in the Argo CD folder? That's a deployment file from the Nginx 1.14. I updated to 1.15. Now, if you go back to the application, now you will see if you refresh these things. Let's wait for it to get refreshed. And now you see, previously it was showing a synced status. Now it is saying out of sync. If you go inside, now if you refresh in my GitHub, in the deployment YAML file, we know the image is updated 1.15. That's why it is saying out of sync. What is out of sync? You can see it is marking it in yellow, right? See, this is out of sync now. If you do sync now, uh, you do synchronous. Now you see, in parallel to this replica set, one more replica set is came and it is created two pods and the old pods are going out. See, now it got synced, back to synced. So I hope you got it. So that's how you do all the installation. You can for Elm also you like whatever it's there. Let me what I do now. Mm, hmm. What I created, I have created the Elm charts here. What I have defined you just now. So I'm going to push this as well. I'm going to give it as default configurations only. uh, what I'm going to create, I'm going to create a new app here. I'm going to create um, Elm Phoenix something, uh, and the project name should be in default and the mode should be manual, and then auto create new subspace, and the URL you just give the same URL here. This time I'm going to install some files under the um, and under the Phoenix folder, okay? Because in Phoenix folder what we have, in the Phoenix folder we have wait, let's get sync. In the Phoenix folder, previously we have just Kubernetes manifest files, but in the Phoenix folder now we have the complete Elm charts here now. So this I'm going to give that now in the Elm Phoenix. uh, just choosing all the same options whatever I seen before, and I'm going to choose create a namespace called Elm hyphen Phoenix, and then I create. Now you see one more thing is get created, and what it says, LM Phoenix is out of sync. Okay, now if I do sync Now you see what is going to create. This Phoenix template is going to create service and service account and deployment. If you do sync and then you do synchronous things. Now see, these things also get created. Replica set is created and a pod has been created. You go back here and then you come and then you do lm create uh, kubectl get all hyphen n lm hyphen phoenix. See, lm phoenix pod has been running, service has been created, deployment has been running, uh, and everything has been created, right? Now, like if you don't need, if you want to delete the entire thing, you just click the entire thing and then give the application name, so it will be deleted automatically. Now if you type, if you see kubectl, see no namespace is there, it's got completely deleted. And then I want to delete this as well. That's it. We are completing this demo. So I hope you got